Right, okay, so last session of the day, but obviously they've kept the best till last, so thanks for coming. And I know you've come here to see me, and it's got nothing to do with the fact that there's a free food after this. But it's half an hour after the session ends, so don't worry, we've got loads of time. So I'm just going to ignore that clock up in the top corner. So I'm talking about, what am I talking about? A recommissioned flexible full-scale wheel rail test facility. It's a bit of a mouthful, but if you know me, I like long titles. So that's just what I'm going to be telling you about. I don't need to go through that. So here it is. Here's the beast. This is the wheel rail full-scale test facility, or the what do we call it for short? FSR, full-scale rig. Okay, so it was actually built by British Rail Research back in the 1970s, somewhere between 1970 and 72, we don't know. But the first published research on it was a paper in 1972 where they actually did some tests on sanding, looking at sanding systems of locomotives. In 2003, it was still in Derby, but it was upgraded significantly, and then it came to the university around about 2011, and we made some significant upgrades to it around about 2013. So I'm going to go through all of that in the next few slides. So this is pretty much how the rig works. So the standard mode of operation is the wheel comes down, controlled by actuator number 1, and then the rail will slide, controlled by actuator number 2, and then we've got a chain that's imparted on the wheel here that imparts a slip on the rail as well. So as the wheel is rotating with the motion of the rail, the chain will pull it at an extra speed, so it can impart a slip. Now, Harold, as I was talking to you earlier, we can operate this chain either in a force or a position control, so we can actually prescribe a torque to the wheel rather than a slip, which actually gives us quite a nice creep curve response. It's not fixed like that, so we can operate the other way around, so we can have it so that the tractive force is in the same direction as the rail travel, i.e. a braking motion, or you can have it in a bidirectional motion as well if you want. It's quite flexible. So this is the rig as it was before it came to Sheffield. That's Dave. And you can see it was grey. And then it came to the university, and I'd just finished my PhD around early 2011. Now you've got to picture the scene, okay? So I've just written my thesis, and my brain is just fatigued. And David Fletcher comes up to me, and it's all right, Dave's not here today, so I can talk about him. And he said to me, do you want to make some money? I'm a poor student. I said, yeah, okay. And he said, I want you to paint this machine. I thought, yeah, okay, what colour? I said, yellow. Okay, it's money. So 4 months later, 4 months, 4 weeks later, we have a yellow rig like that. Took me about a week to degrease it, a week to undercoat it, and then 2 weeks to actually paint it. So it's actually a really nice job, just straight after a PhD. I really recommend it. Just set yourself up as a painter and decorator. It's great. You just don't have to think about anything. You just do it. It's on autopilot. Yeah, it's a really good way of relaxing and earning some money as well. So as you can see, now when you come to the University of Sheffield, I really want you to check this out. So ask Roger. Roger, get prepared for the influx of people to come over to the university, and look at these lovely facets here. So David wanted me to paint the whole thing yellow. I thought that was a bit vulgar and ghastly. So I used my own artistic penchants, I don't even know if that's the right word, it sounds intelligent now, but to keep these bits inside here grey, and I think it's a lovely contrast. So when you come over, really do inspect that, have a look round it, make sure it's clean, please, somebody, because I don't work there anymore. And just remember, you saw the face here when you're looking at the rig. So, important stuff. So, we added a new control system. So this is the old control system over here. It was 2 big filing cabinets worth of 1970s electronic equipment. Now it's just controlled by this PC down here. It's got a LabVIEW interface at the front, and it's a lot more versatile than it was. And as you'll see in the next couple of slides, we've added a fully interlocked safety system around it, so we can leave the rig running 24/7 with minimal supervision. If you open a door, it will just stop. So it's nice and safe. You can just leave it running, and if you want to do a long test, that's ideal. You just leave it running 24/7, and you'll get your results at the end of the day. So this is pictures of the first ever test that we did. So we're looking at sanding systems. So we've got a sand hopper there on the back of the rig, blowing sand into the wheel rail contact. We had a high-speed camera to catch the sand flow so we could look at particle speeds. We had the air compressors to actually blow the sand itself. It's quite a nice project. That's pretty much everything on there. Yeah, we made some changes to the clamping system of the rail. So when we got the rail, it accepted an old BS standard profile, which was quite small. And we wanted to, when we were doing new tests, we wanted to do something a bit more modern, like a 60E2 profile, which is a standard European profile, but it's a much bigger bit of rail. So we had to change the systems to, I'm not running out of time, no, I'm not, to accommodate that. And a few other mechanical changes as well. So recommissioning something like this, there's a lot of obviously electronic and software stuff that goes on, but there's a lot of mechanical stuff as well. So for example, what happens when you want to take the wheel out of the machine? It's not an easy feat. We had to work out how to actually do it. As you can see in previous slides, there is a cap on the top of the machine, so you can't get the crane directly over the top of the wheel. And the last thing you want is a 500 kilogram pendulum swinging around in your lab. It's probably not much fun. I've not experienced it, but I don't want to. So we had to come up with a system of doing it. So we needed 2 secure systems. We had to attach the wheel to the crane, but then we had to have a secondary attachment to an anchor point, and we had to swing the wheel out from underneath the top frame of, sorry, I'm rubbish with this microphone. We had to swing the wheel out so it was directly under the crane and then take it out. What happens when the chain breaks? That was a pain, and unfortunately it happened in the middle of a test. Again, you can't just buy these things off a shelf. I had to find out what it was. Is it a standard product? Do we have to make it? Fortunately, we didn't. I found out a company that made them. We got a new one. When you take the wheel out, how do you get it on the ground? It's got this big stub axle in the middle of it, so it won't lie flat on the ground. We had to get some jacks from a local hardware store. We had to get some hydraulic jacks because it's got some big counterweights on it. How do you take them off without killing somebody? And just various different things that we had to learn. So it was all fun and games. So that's how it looks today. Nice yellow and blue motif. Again, remember the nice grey facades in there. Check them out next time you're over. Right then, so some of the stuff that we've done on it since it's been upgraded. So we've done a project on laser cladding. So we've done a pilot project before this, looking at different cladding materials, so materials that we can clad onto the top of a standard grade of rail. We'd found 2 that performed quite well at a small scale, but how do they perform at the full scale? 2 different types of tests. So we did a tangent track, and we did a simulated IBJ, because IBJ lipping's a problem where you've got material flow. Just to put a long story short, they both performed quite well and reflected what we were seeing in the small scale tests as well. This is a little bit of the sanding system work that we did. There was too much to really put in. So as you can see here, we put down a paper tape to simulate a low adhesion layer. And as you can see in that graph, that's indicated by that red line there. So you can see it's quite nice and low, well below 1.1. And then we tried firing some sand particles in there at different hose orientations, putting nozzles in the hose, different pressures, and what have you. And the results, you'll find out more by reading the paper, to be honest, than listening to me. But you can see there's some examples of high-speed footage there where we looked at the sand flow rate, how the sand particle speed changed as you look at the depth through the hose. And the biggest finding from that project was when we put a side wind onto the machine, just a 40 mile an hour side wind, which I'm not sure what that is in kilometres, about 60, was enough to completely blow the sand away from the interface. So a lot of these problems where you get low adhesion, that's probably something like that that's happening. The sand's not reaching the interface. I am adamant that all you need is a few grains of sand in the contact and you will overcome low adhesion, which is what we've seen, what we've shown in these tests, and that's published work now that you can go and have a look at. Last but not least, this was another, I wasn't really involved in this project, but this was looking at using ultrasonics to measure the contact patch between the wheel and the rail. There's some results here at different forces. As you'd expect, the contact patch gets bigger and your contact pressure gets bigger as your axle load increases. These tests were done early on when we had a severely hollowed wheel that we'd inherited from its previous owners, and that gave you this funny double contact that's going on. It's actually a triple contact. So, the pièce de résistance. This is my personal parting gift to the university. It's the pocketed rail solution. So the problem with a massive, big bit of rail is that it's heavy, it's long, it's heavy. You can't really do a lot with it. You can't put it under a microscope. You can't really weigh it, because I haven't found a set of weighing scales yet that can weigh 60 kilograms down to 0.0001 of a gram, which would be nice. So when we inherited the rig from British Rail, it came with an old British standard profile which had a pocket in it, and I thought maybe we can adapt that into a new rail profile, and here is the result. So we've got two different, we've got a short one which is good if you want to build up layers in the rig like a leaf layer or a friction modifier layer. You can take the segment out, put it under a microscope. These are some 3D scans here that we've done so we can have a look at the actual contact band, how it's changing over time, measure the roughness, measure the mass loss, and whatever you need. And then we've got a slightly longer segment here where if you're looking at more at wear test, and the advantage of the longer segment is that you can keep the contact within that segment. So you've got no issues with the wheel rolling over the transition from the rail to the pocket. So that pretty much sums up that. Oh no, yeah, the summary slide was what I just told you in the last 20 minutes. It's good, go see it, go check out those facades, they're amazing.
Okay, thank you very much.